Hey guys, today we're doing section 1.6, other types of equations. So we're just going to learn how to solve some different types of equations. Some square roots, some absolute values, and some polynomials. So factoring, I feel like we've done so much of this lately. Get everything to one side here, 4x to the 4th minus 12x squared. Always look for a GCF. My GCF here is 4x squared. So we're going to factor out that GCF, and we're going to be left with x squared minus 3. And the reason you want it to equal 0 is because you can have 4x squared equals 0. Divide by 4. X squared equals 0, and square root x equals 0. There's one of my solutions. And then you could have x squared minus 3 equal to 0. Add 3 to both sides and take the square root. Remember, you're going to get two answers here, positive and negative square root of 3. So we got a total of 3 answers going on here. 3 solutions, 3 roots. Next one, solve by factoring. Again, get everything to one side. So we've got 2x cubed plus 3x squared. We're going to subtract 8x minus 8x. We're going to subtract 12 minus 12 equal to 0. This to me screams grouping, factoring by grouping, because I see those 4 terms. So I'm going to group those first 2 together. It looks like they have an x squared in common that we can pull out, that GCF. So we're left with 2x plus 3. And then I'm going to group those second 2 together. It looks like they have a negative 4 in common. So I'm going to go ahead and divide that out. So we're left with 2x plus 3 equals 0. And now you can see that GCF occurring in both of them. So now we can factor out 2x plus 3. And when you factor out a 2x plus 3, you're left with x squared. When you factor out a 2x plus 3, you're left with minus 4. So again, 2x plus 3 can equal 0, or x squared minus 4 can equal 0. So here, subtract 3, divide by 2, x equals negative 3 halves. All right, subtract 3, divide by 2, there's one of my solutions. Here, add 4. Take the square root, and remember you're going to wind up with 2 answers, plus or minus the square root of 4, which is 2. And there's our 3 solutions. Okay. So let's move on to radicals. Remember, the opposite of square rooting is squaring. However, I really don't want to square this right now. So my advice is to get your square root alone if you can. So I'm going to go ahead and subtract 3 from both sides. So I'm going to have square root of x plus 3 equals, and then I'm going to go ahead and subtract that 3 from both sides. And now I'm going to square both sides of my equation. So we're going to take this side and square it, and we're going to take this side and square it. So squaring and square rooting will cancel each other out. We got x plus 3. Here, remember you got a FOIL, so you're going to have x squared. You're going to have negative 3x, and negative 3x makes negative 6x, and negative 3 times negative 3 gets you positive 9. And that was just a quick FOIL, so hopefully we're good with foiling now. And I see a quadratic going on here, so I'm going to get it equal to 0. So we subtracted x and we subtracted 3. So subtracting x gives me negative 7x here, and subtracting 3 gives me plus 6. Okay. We're going to try and factor. So we want numbers that multiply to 6 and add to negative 7. So we got negative 6 and negative 1. Multiply to positive 6 and add to negative 7. So your 2 answers, you got x minus 6 can equal 0. So x equals 6. Add 6 to both sides. And you have x minus 1 can equal 0. So x equals 1. There's your second answer. Now I will tell you, when you start squaring, sometimes you introduce extraneous solutions. And what I mean by extraneous is when you substitute these back in, it does not work. So you definitely, when you square something, you want to test that your solution works. So let's go ahead and check them. Let's plug in 6. 6 plus 3 equals 6. All right, so I just plugged it in for x. So you got square root of 9 is 3 plus 3 has to equal 6, and it does. So yes, that is a solution. Let's check 1. Square root of 1 plus 3 equals 1. So square root of 4 is 2 plus 3 has to equal 1. 5 definitely does not equal 1. And that's what we call an extraneous, so that's a negative. We don't want that one. That is an extraneous solution. And they just pop up when you start doing weird stuff like squaring both sides. So you definitely always want to check your answers and make sure both of them work. And they could both work. So they could both work. One could not work. So don't just assume because one works, the other one's definitely not going to work. Test them both out and make sure. Now here, if you have two roots, you want to try and get one on each side. So we're going to go ahead and add that one over. So we have square root of x plus 5. And over here we've got a 2, and we're going to add root x minus 3. And no matter how much you try, this one's not going to look pretty. This one's definitely not going to look pretty. So we're going to square both sides now that we have a root on each side. And that right side's going to look a little rough. So here, squaring and square rooting, we're going to left with x plus 5, right? They cancel out. Here, that is a really, really rough FOIL here. So I'm going to just do it below. 2 plus x minus 3 times itself, right? So 2 times 2 is 4. 2 times root x minus 3 is 2 root x minus 3. 2 times root x minus 3 is 2 root x minus 3. And root x minus 3 times root x minus 3 is just x minus 3. Right? Squaring and square rooting cancel out. So 4 minus 3 leaves me with 1. 2 of them and 2 of them make 4 of those root x minus 3's. And an x. So we're going to go ahead and write that on this side. 1 plus 4 root x minus 3 plus x. Okay. So now on this one, you have a root still. But now you went from 2 roots to just 1 root. So you want to isolate that root, and then you can square both sides. So we're going to subtract 1 for both sides. We're going to subtract x from both sides, and they actually cancel out, which is really nice for us. And we're going to go ahead and divide both sides by 4. So now that you have your root nice and isolated, you can go ahead and square both sides. So we've got 1 equals x minus 3. Add 3 to both sides. X equals 4. Again, when you start squaring and square rooting both sides and stuff like that, you get those extraneous solutions, so you definitely want to check. Definitely want to check your answers. So what do we got? 4 plus 5, and then 4 minus 3 has to equal 2. So square root of 9 is 3, square root of 1 is 1, 3 minus 1, oops. I'm just going to scribble it out. Has to equal 2, and 3 minus 1 does equal 2. So we're good. That is our answer. We're going to box it in, and we're going to move on. Rational exponents. So rational exponents, you actually want to think reciprocal. So if you want to get rid of 3/2, you multiply it by 2/3. So we're actually going to raise it to that power, though. Okay? Power to a power, you multiply. So we're going to raise it to that power. But we want to get it alone first. So we got 5x to the 3/2. We're going to add 25. We're going to divide both sides by 5. And here's where, again, to raise a power to a power, when you raise a power to a power, you multiply. So to get rid of that 3/2, we actually want to raise it to the 2/3 on both sides. So that'll be x to the first power, which is why you did it. And here we have 5 to the 2/3. You can actually leave it like that, or my advice is to always just double check and make sure nothing simplifies. Power over root, remember power over root. So it's saying 5 squared is 25, and we want to take the cube root, which that does not simplify, so that could also be your answer. So either of those is good, exponential form or radical form. All right. And again, just double check your answers, make sure they're good. So let's check it real quick. 5x was 5 to the 2/3 to the 3/2 minus 25 has to equal 0. Here, 2/3 to the 3/2 multiply, you get 1. 5 times 5 is 25. Minus 25 is 0, and we're good. Let's add that 8 to both sides. So we get positive 4 now. And again, to deal with that root, we're going to multiply it by the reciprocal. Sorry, raise it to the reciprocal root. So 2/3, we're going to use, oops, get out of there. We're going to use 3/2 on both sides. So here you've got x. And be careful here, because power over root, you're actually taking a square root. So we're going to wind up with 2 answers, plus or minus. Power over root. So we want a square root of 4 cubed, which is 64. That one does simplify, right? You get plus or minus 8. So there's your x. Again, plug it in and check. Plug it in and check. 8 to the 2/3 minus 8 has to equal -4. So power over root, 8 squared is 64, the cube root of 64 is 4. Oops, minus 8 has to equal -4, and it does. So positive 8 checks out. If you put a negative in there, it winds up being the same thing, okay? Because once you square it, the negative goes away anyway. So -8 is going to work as well. Quadratic form. So sometimes they're very similar when we had those x squared minus 5x, right, plus 6 equals 0. And we said, oh, it's quadratic form, right? And we could say multiplies to 6, adds to -5, and we could go from there. This is super close to that. So what we're going to do is we're actually going to say, we're going to use the letter u. And we're going to substitute, we're going to say u is x squared. So we're going to write this with u. So this is actually u squared, right? X squared squared minus 5u plus 6 equals 0. And the reason we did that is because now we can factor it just like normal, right? We say multiplies to 6, adds to -5, so u minus, oops, I said 2. u minus 2 and u minus 3. All right, multiply to positive 6, subtract, or sorry, add to -5. So you get u equals 2 and u equals 3 as your answers, right? But then you have to go back. You have to go back and say, well, u was actually x squared. So really we have x squared equals 2, which means square root x equals plus or minus square root of 2. Here, again, u equals 3, but really x squared was what equaled 3. Square root both sides, x equals plus or minus the square root of 3. So there's my 4 answers. Positive root 2, negative root 2, positive root 3, and negative root 3. So I'm actually about to run out of time. So I'm going to pause this video and I'm going to pick back up and do a part 2.